Hello, everyone. Today, I'm excited to show you how the AI Run platform leverages AI agents to automate and streamline real enterprise workflows. Forget generic Hello World demos. We're diving into a real project scenario where AI supports key team roles, orchestrates backlog items, and accelerates code delivery with real integrations. Picture this. You're a product owner or solution architect wanting to add new features to your project. You schedule meetings with technical folks to discuss and brainstorm, but what's next? Traditional SDLC means planning, breaking down activities, and moving slowly without fast prototyping. Let's see how this works in an AI-native SDLC. Meet our AI assistants. Clara, our business analyst who analyzes meeting transcripts and creates stories with requirements. As you can see on the workflow slide, Clara is connected to multiple tools. She can analyze transcript files, connect directly to Jira for story creation, and access our comprehensive user guide for context and requirements validation. Next is Tessa, our QA engineer who generates test cases for different scenarios. In our workflow, Tessa integrates with both Confluence and Jira. She reads existing guidelines and test cases from Confluence, generates new test scenarios based on user stories, and automatically creates them in Jira using proper formatting. Then we have Archie, our solution architect who designs features technically with implementation specifications. Archie has deep access to our codebase, understands existing patterns and system architecture, and can generate comprehensive technical designs and API specifications that align with our established development standards. And finally, the implementation phase, where we're ready to develop the front-end based on user story requirements. Here we can use different options. Choose your preferred IDE with Microsoft Copilot and connect via MCP, or use our native IDE plugins. In our IDE tools for JetBrains, we have developer agents connected to Jira that can implement front-end parts based on all the prepared materials from previous steps. This end-to-end workflow shows how these assistants collaborate seamlessly, passing context between each other while maintaining connections to all necessary tools and documentation. Let's move to our case in details. At AI Run Platform, we have different data source types and connectors, like files, Jira, code, but today we're adding a new one, FTP data source, to fetch and process data from different FTP servers. Here's our meeting transcript where we discussed this new functionality with our solution architect and UX designer. This transcript can be fetched from almost any communication tool, like Microsoft Teams. Let's move to the AI Run platform. Here's Clara with defined system instructions connected to Jira and existing project requirements and user guide. Our user guide contains detailed platform specifications and documentation. Let's ask Clara to analyze our transcript and extract user stories and requirements. In moments, she provided a draft with requirements. Looks good, but I want to adjust the spec since my front-end team may ask additional questions. Since this is conversational, I'll ask for a table with required and optional fields for the UI. Here we are, Clara suggested a new draft. I'm satisfied with this version. Let's ask to create a user story and link it to our epic in Jira. While Clara works, let me show you assistant configuration. There's an option to completely configure assistants using natural language. I provide information and AI does the setup. Let's create a similar Clara agent. Everything's done. Assistant name, description, starters, well-structured system instructions, and required tools like Jira. You can also use different LLM models and MCP servers as external tools. Let's switch back to Clara. She created the story. Let's open it. It has a well-formatted description with clear content. Next step, generating test cases with Tessa, our QA assistant. Let's ask her in the same chat to generate test cases. Nice thing. All assistants can share context and support each other. Tessa finished her work and test cases are created. Let's check Jira. Yes, test cases are created in Gherkin format. Now we need technical design and API specification using Archie. Archie knows our codebase, patterns, and system design. He'll make technical design for this brownfield project according to existing patterns. Let's ask Archie to make API specification. In moments, we have this work done. We can export to PDF or put it directly into Confluence or Jira. Let's check export results in PDF file. Looks pretty well. Now we're ready to implement the front end based on user story requirements. We can use different options. Choose your preferred IDE and tools like Microsoft Copilot and connect via MCP, or use our native IDE plugins. I'll use our in-house tools for JetBrains IDE. In the IDE plugin, I can choose my developer who's connected to Jira and can implement front-end parts. Let's ask him to implement the created user story. It takes time for the developer to analyze the Jira ticket, examine necessary codebase parts, and do the actual work. In several minutes, it finishes. Let's check our local environment. On the data source page, we have the new FTP type available. Let's choose it and see details. Nice! The agent implemented everything according to requirements, including validation rules and backend integration. We can implement the backend side similarly, including unit tests and other relevant components. Of course, assistants aren't deterministic and can fail sometimes. That's why developers are needed to polish and fix implemented work. This is the flow of our new approach to AI native development pods and the way to become AI native with faster prototyping, productivity gains, and improved time to market. See you in next videos.